All right, this part of our notes is actually a callback to our syllabus topic 2.4 with the rational function and looking at the graphs with its asymptotes. So we're going to connect this now to the idea of limits. And so if we think back to what we had last year, if I think about this function and its asymptotes, I know that basically I've got a linear divided by linear. So if you remember, we've got same order, which means that our horizontal asymptote, there is a horizontal asymptote, not oblique. So oblique asymptotes happen when the order of the numerator is greater than the denominator. But here our horizontal asymptote is going to be y equals 2. So if I think about this in terms of limits, I've got my limit as x is going to infinity of 2x plus 3 over x minus 4. Well, I would get infinity over infinity, but if I divided through by x, I would have the limit as x is going to infinity of 2 plus 3 over x over 1 minus 4 over x. And now as x goes to infinity, positive or negative infinity, these are going to go to 0, and I'm left with 2. So that's why my horizontal asymptote is y equals 2. I'm going to have a vertical asymptote at x equals 4, because that's where I divide by 0. So those are my asymptotes. I can graph it. I also want to think about x and y intercepts. So when x is 0, I've got negative 3/4 as a y-intercept. I know that the y value is going to be 0 when my numerator is equal to 0. So that's going to be at negative 3/2. So I can think about all of these things when I'm creating my graph. So I'll put in some axes, and let's count with ones. So then negative 3/2 as an x-intercept here, negative 3/4, that's 1, so we'll have a y-intercept there, x equals 4. Over here, y equals 2. Around here. Clearly I could have scaled this a little bit better because now I've just got huge amounts of space, but I know that I'm going to approach my asymptote. I'm only crossing the axes here, so that gives me a hint that my graph must be something coming in here. This way, I could plug in other points to have it be more accurate. I can also think about my values. So this is x equals 4. At x equals 5, I'm going to have positive values. That also gives me a hint that I'm up here. When x equals 5, I have 13. So that value is going to be way up here. Again, clearly scaled terribly, but this set of arms on the graph is going to be up here. So again, to summarize, we have our rules from last year that maybe you remember, and if not, you should look back on those notes, and we can use all those ideas to help us think about functions like this. So here I've got a numerator that's order is bigger than the denominator. So if I use my long division, then I can rearrange this function. So x goes into 2x squared plus 0x plus 10. I'm going to have 2x squared, and then 0x plus 10. So that's going to be 2x, and my remainder is going to be, so I could say that y is equal to 2x plus 10 over x. And this then tells me that my limit as x goes to infinity of 2x plus 10 over x is going to be 2x. The limit is going to be infinity, but it's going to be approaching infinity in the form of 2x. So that's going to be my oblique asymptote. So oblique asymptote is y equals 2x. Vertical asymptote at x equals 0. And I can use those ideas to help me make this graph. Again, finding x and y intercepts as well. Not that there are any x-intercepts or y-intercepts, actually. So let's go ahead and graph this. Knowing there's no x or y-intercepts also helps me think about where my arms of the function are. So we have this also this way. So my function has to lie here and here, because if I was on this side, I would have an x-intercept. I could also think about plugging in a value. When x is 1, I have positive numbers. If x is -1, I'm going to have negative values. So again, following my asymptotes, if I wanted to plot some exact points, I could. I don't know exactly where this is at the moment. We're going to be figuring that out later.